guess we should have been in the bigger room. So I'm Matt Cave, and I'll be introducing today's speaker. So we're pleased to have Kelly Pennell from University of Kentucky. She's, among other things, the director of the Superfund Research Center. And I think it's great to have UK and U of L as one big happy family here in March Madness. Both teams played yesterday afternoon and won, and they both play again this afternoon. I got to figure out how I'm going to make it through clinic at HCOC and not miss any of the games. So I've worked with Kelly on the external advisory board for their center. Several of us, including myself and Banrita Wolong, have worked with Kelly in the UK Superfund Center. She's unique for many reasons. Are there any other engineers that lead Superfund research centers? There are a few. So she's not unique there, but one thing that she is unique with, and she reminds me a little bit of Rob Kenton, who used to be here, and that she can seamlessly work with the biomedical researchers and the engineers. And so that's a very unique skill set. She's trained at the best engineering universities in the country. Including Rose Holman, where she received a master's in environmental engineering, and then Purdue University, where she received her PhD. She's an expert at the topic she'll be speaking on today, and I spoke with her a little bit this morning about some of Ted's work in Calvert City, because I suspect there's a vapor intrusion problem going on down there, and that potentially we might be able to work together on that. But anyway, appreciate you driving over, and thanks for giving the talk.
It's always great to be at the University of Louisville, and it's always great to be invited to give a seminar when you just have to drive an hour and a half. That's really great to be at another wonderful university here in Kentucky. So the title of my talk is Identifying and Mitigating Chemical Exposure Pathways at the Subsurface Building Interface. We'll get more into what that is. And you will see if you look at it, I am unique. So that's actually a great thing to say about me. Biographical overview, Matt said some things. I actually started working in industry when I first graduated with my bachelor's. So I worked in industry. Arcadis is a consulting firm. Interestingly, that works for industry, or a consulting company that works for industry that pollutes sites. So the regulated entities. And then I went on to Brown University, did state policy liaison work. Also then developed a large research portfolio, now faculty. Interestingly though, when I worked at Brown, I started interacting with a lot of sociologists and social justice work. And one of a really renowned social scientist said to me, Ellie, how can I work with you? You work with the bad people, right? And I was actually kind of taken aback. And since then, I would just say that this engineer continues to give education in social science. So I am really here. I've worked with sociologists, anthropologists, and I'm not one, but I at least appreciate that there's a lot to learn. I've also worked with biomedical researchers. So I'm really, really transdisciplinary, even though I'm pretty engineering. I have more than $50 million in externally funded research. One of the things I first started doing when I became multidisciplinary interested was I worked as part of a center funded by NASA and worked on mission to Mars scenarios. So even then, we were looking at really human-centric research questions about how to keep a human mission to Mars sustainable, but considering engineering scenarios too. So we actually had a Mars toilet in one of our labs, and we were looking at growing tilapia and other foods and keeping, an mission to Mars as short as you can make it is 18 months. And so that was a very multidisciplinary thing. And then since then, I've been really engaged in environmental health and pollution and how health and the environment interact. So today, what I'm going to focus on is I'm going to give you a brief overview of what we do at the University of Kentucky Superfund Research Center. As a director, I always have to do a little bit of PR on that, remind you what we are and what we do. And then I'm going to talk about an expertise that is very near and dear to me, which is vapor intrusion, something that we developed, sewer gas intrusion, and then some work we've been doing recently at a Superfund site out in California called the MEW site. This is my deputy director and myself, University of Kentucky Superfund Center. We focus a lot on persistent halogenated organics. So we looked at PCBs, tetrachloroethylene, trichloroethylene, and then now PFAS. And we just aim to reduce the toxic complexities and then promote health equity in the community. That's very broad, big picture, but I'm going to say in a nutshell, that is what we do. I'm sure most of you already know this, but I'm going over it anyhow. So Superfund research programs were started by an act of Congress dating back to 1987. Our Superfund Research Center at University of Kentucky was funded beginning in 1997, so 10 years after that act. So we've been funded quite a long time. And our stakeholders are things like DOD, DOE, and when I mention them, those are considered polluters. Those are entities that have caused pollution now it needs to be cleaned up. And then also entities that are part of regulating or assessing health risks like EPA and CDC, ACSDR. Also local and state agencies, and then generators of hazardous waste sites, various industries. We work with all of them. And then also we're conducting research, biomedical research projects, engineering research projects, and training is a huge part of it. We care a lot about our graduate students and postdocs. So we have 2 biomedical projects, 2 engineering and or environmental science engineering projects, and then we have 4 cores that are supported to us. This is, just showing the timeline of our Superfund Research Center. As you probably know, Kentucky has 13 Superfund sites that are listed on the national priorities list. I show this site down here, which is listed in the bottom picture here. This is a Superfund site that we visited when a community member called us concerned. This site is down in Harlan, Kentucky. So I like to show this site just because it was at the time when a community member called us listed as a redeveloped site. So back at that time, EPA had on their website lists of kind of success stories, but it was just, and I'm sure it was just, no one went and checked. We often say in Kentucky, we have forgotten communities and forever chemicals. And so this is Harlan, Kentucky, and this was listed when we first started. I had students like, well, let's look up and let's dig in and see what this is. This was listed as a redeveloped Superfund site. Okay, so we were curious what we were going to see when we went down there. This is what we found. Now, the Superfund site, when it was originally listed on the MPL, was really just that building, and it actually was coal machinery. The redeveloped part, does anyone know what it was redeveloped as? Auto salvage. And you know how many employees that redeveloped? Because at that time, it was like listed as like, oh, this is a success story. It's actually, redeveloped, it's rebuilding our economy down in Harlan, Kentucky. How many employees were listed? 1. So it's actually, now the website has been updated a bit. It just says like current use, and it looks like redeveloped data before. It's not quite listed as it used to be. It's like redeveloped success story. But this is what we found. And then as we kind of did more of a Superfund review on this site, we saw that, or we learned from community member interest, are there still exposures there, what's happening? It was primarily PCBs, but now it also had this issue of vapor intrusion because those cars had not been drained of fluid before they were smashed. And so, again, forgotten communities forever chemical. No one was really doing oversight. It was just a location where they could stack some chemicals or some cars up. I just think that's it's kind of a too common of a story. in different rural areas, not just in Kentucky, but in a lot of areas. I grew up in a rural area in Michigan. I'll say that doesn't, I could probably, if I drove around parts of where I grew up, I'm sure I could find a site not too dissimilar from that. On the other side here, where I show the state of Kentucky, these are locations of industrial pollutants. These are just locations where we have industries that are using pollutants. You'll see that they're all over Kentucky. I like it when I meet with communities and industry and remind them that this isn't a problem. We may have areas where in geographies where they're more concentrated, but in fact, we have industries spread out throughout our state where chemicals are used. And it doesn't take long to get somewhere where we could be, our communities are exposed, have the potential to be exposed to chemicals. And so, like down in Harlan, for instance, when that company moves out and leaves waste, it's quite expensive to pick it up. And so what we really do in our Superfund centers, we do a lot of mapping, we do a lot of geospatial analysis to kind of look at where are these are locations that might be vulnerable to areas where have been forgotten or not currently looked at. Where are releases likely? Where are these, and I do fate transport modeling, so where might we have drinking water exposures, different things that are being overlooked. I won't get all into that. So these are just some pictures. Actually, Ben Rita is up there in the middle there with a red sweater on, for those of you who know her. That was actually at a UK U of L trainee gathering. They went down to Whitesburg to the farmers market, which is one of our community groups, and we did a meet the research and meet the community group. So we've had a long legacy of trainees. Since 1997, we've had hundreds of trainees enter the workforce, many successful collaborations, not just at UK, but across. We've collaborated with U of L, we've collaborated with many of the other Superfund research centers, and there's over 22 nationally. And to me, that's one of the funnest parts of being one of these centers. Dozens of patents and hundreds of publications. In just the last 5 years, 40 of our trainees have entered the workforce. And for me, I like to say that I focus more on producing researchers than producing research products. That's important to me as a center director. I want to produce people who are high-performing researchers so that we're growing researchers, and wherever they go, they are kind of, trained differently and better so they can go produce more research. And that's the impact we're having. And yes, by the way, we've also produced a lot of publications, so we've generated that kind of science, and we filed a lot of patents. So, but that is my PR plug for my center that I love so much. We'll move on into some research that I do, and that is vapor intrusion. So to start off, what is vapor intrusion? So it's estimated that nationally we have about 400,000 hazardous waste sites in the United States. So that would just mean sites where we know that there's chemicals that have been used, and they need to have their waste managed in some way. There's probably been a release of some type, and a release can occur in many different ways. 25%, or about a quarter of these, are considered at risk for vapor intrusion. We consider them to be vapor intrusion risks when they're volatile. They have a volatile compound. And vapor intrusion occurs when they are there's volatiles in the subsurface, and they could migrate upwards and then impact indoor air. So when you think about that, think that there's about 100,000 of those sites, not just buildings, but sites across the United States and nationally. At each of those sites, there's tens to hundreds of buildings that could be impacted by these vapors that migrate upwards. So when you do the math on that, it turns out that there are tens of millions of buildings that have the potential to be impacted by vapor intrusion exposure. I mentioned that just to let you know the size of the problem. So there's an entire industry built around vapor intrusion, mitigating it, fixing it, and it is a problem. I say that because when I first got into vapor intrusion and started kind of thinking about it, I wasn't convinced that vapor intrusion was the real problem. I always have to be convinced there's a problem. I have to look at the data, I have to see the evidence, I have to measure things, make sure we're actually seeing it. And I wasn't convinced that this state transport, this exposure pathway could really exist, impose a health risk.
And this is one reason. So when I worked in industry, this was one of the sites I worked on. I was mostly involved in this part of the site. And if you look here, this fence line here was where me, as my good little engineer, and you can see why the sociologist was pretty annoyed with me, because I never left this side of the fence. I stayed right over here where the industry owned. A good little engineer working, hired by the industry, never wanted to go over into this community. As an engineer, I wasn't trained to talk to these community members. I just stayed right over here. In fact, if you look, you can kind of see like there's like groups of three. So here's three, here's three, here's three. They're little tiny boxes. Those were actually remediation systems. So they were pumps. We had those pumps set along the fence lines that we would intercept contamination before it went up. There was considerable contamination at that site. It was originally a DoD site. General Motors bought it, then Rolls-Royce. They did R&D. There was many things going on that site. So at one point, there was contamination that had gone on here. The community had been hooked up to drinking water, public water. So no risks, no risks. I left industry, but this was like a site that I literally pulled all nighters on as a consultant. You're billable as a consultant, so you work really hard. I convinced myself there was no risks there. You know, like we followed regulations, we were good. So I left, I went on to Brown, and I was partnering with the Rhode Island Department of Environmental Management, and they said, you know, Kelly, what we really need help with is this problem of vapor intrusion. I'd heard about vapor intrusion when I was a consultant, and I always thought that is not real. And I said, I don't think vapor intrusion is real. I don't know they have anything to worry about. And they said, no, it's really coming to us here in Rhode Island. Rhode Island's interesting and unique, to use that word, because it's like the size geographically of Lexington, but it's got all the burdens of a state. It is the population of about Louisville. It's 1 million people, the size of Lexington, and all the burdens of protecting the state, right? So it doesn't have the budget of that. It's a and it was like the birthplace of the Industrial Revolution. Plenty of contamination. Really, really rich, interesting complexity there. I loved interacting with Rhode Island Department of Environmental Management. So I listened to them and I really took them seriously. So I dug into this vapor intrusion problem. Turns out it was a real issue. So I called back, my old consultant friends, and I've been gone now for a while, and I said, are you guys dealing with vapor intrusion out there? And I said, Kelly, you won't believe it. Yeah, the regulators are making a field test. Can you believe we now have to go in and sample every single one of these homes, indoor air? So earlier I could remember one site can include 10 to 100 homes. This is one site, but look at all these homes. And each one you have to go up and knock on the door and say, can we get access to sample your home? Can we maybe sample some soil vapors? It's extremely intrusive. And they may say, no. Plus, you've already told them, we ensured you were safe with hooked up to public drinking water. Now you have to go in and say, your indoor air might not be safe. It's just extremely invasive. It's trust breaking. And so this whole thing just really was like, it was really just lit my heart on fire on this day. And I had to go, wow, this became an area that I got really passionate about for research. I started writing grants, and hence is now my whole research area. Vapor intrusion is a community issue in a way that I'm even just going to say drinking water is not. When someone is impacted by vapor intrusion, it's their indoor air space, and they do not have a choice not to breathe their indoor air. You cannot put them on bottled air, and there's just no choice for them not to be exposed. And the mitigation scenarios become very difficult to work through. So it's very complex. This is an engineer's mental model of vapor intrusion. And when you go, let's just say in that community or any community I've worked in, you have to first knock on the door and say, I think you might have these vapors from the subsurface coming up into your indoor air and potentially causing cancer or all these other things. And this is how we think it's occurring. I mean, it's very complex. And again, I didn't even believe it was happening at first. And so some people say, I don't even want you here and I want to sell my house next year and you're just going to hurt my property values. Other people say, okay, come in. But we don't even understand this. And we have all these conceptual models like this. And at the time, there was very few numerical models. And we were getting so many different values. Like one house would have a measurement, another one wouldn't. We didn't understand it. So we started, again, as an engineer, I said, well, I can do a better job modeling that. So we started developing 3D computational fluid dynamics models. And that was with Rhode Island Department of Environmental Management. I said, well, I'll develop a better model. I'm an engineer. Let me jump into this. So we started developing these, we started publishing them. We did a better job. We started doing better and better. And then Massachusetts Department of Environmental Protection said, Kelly, we're having some trouble in this neighborhood. Could you come and help us there? And I said, absolutely. So we worked with Boston University School of Public Health, and then also Brown, and then I was working with UK. And we went into this neighborhood outside of Boston. And you'll see this is a school here. So this school had detection of trichloroethylene in indoor air. And they had some of these homes that had PCE in them. Some homes didn't. And they couldn't figure out why, and the community was getting very frustrated. Why is this home getting mitigated? Why am I? Why do they have? And I had been very convincing to these regulators. And I said, you have that fancy 3D model. Do you think you could explain? Do you think you could collect some data? Oh my gosh, I'm sure I could. So here we are out there collecting data and convince these people to let us put in things like a geoprobe and move into their backyard. I was very courageous at this point because we, couldn't get utilities. We didn't. We sampled beneath their subslabs. These are two of our research assistants. And the data was decent until we encountered this problem. And some of you probably have already seen me present this. This is a notorious thing that we have published way back in 2013. But we realized that we were getting higher concentrations on this first floor in one of these homes than in the basement. And this home was supposed to be not really a control because you're in the real world, nothing's in control, but we shouldn't have seen anything. Because they had already mitigated the basement, they had sealed it with epoxy, and they had an operating mitigation system. So why were we getting anything on the first floor? The engineer in me said, I'm pretty sure that that is a lab artifact. I'm pretty sure someone else made a mistake. My 3D model would not make a mistake. And of course, the public health scientist said, Kelly, we should worry about exposures. And I said, no, we should worry about my model. And so we went back and forth. One of the other engineers ran away, like fear hit them. They ran away and they said, don't lean into this mess. And the public health scientist, who is still a very near and dear friend, said, let's really lean into this. So we did. And we talked to our research assistants to continue to say, no one else would make us do this, but Wendy Hickerbernays and Kelly Pennell. And we just kept talking. I said, what's different about that house? And they said, that's the house we keep sampling. Why do we sample it? We just kept asking why? Because it smelled like sewer gas. Horrible. We go in there and we act like it's our worst house. And we said, you never told us about the sewer gas before. We're like, well, it's in our note. Okay. And I said, I don't think sewer gas is going to be doing anything. But, that's not the way TCE or PCE smells. It doesn't smell like sewer gas, blah, blah, blah. And then the homeowner said, yeah, actually the tenants always move out of that. They don't like to stay there either. I can't do tenants in that because of the sewer gas. I mean, this is an older home outside of Boston. So there's no known sources. We had done a complete inventory. So what was going on? Well, it turned out that the toilet had a leaky wax seal around it, if you've ever had a wax seal around it. And there was sewer gas coming up around that wax seal. Now, it took a lot of the research assistants called it CSI. And then only we would they would say, they text and they would say, are you going to make a that toilet? And I said, you're going to have to. And, it was just ongoing. But of course, I was so nervous. And then, the other professor, Wendy Hickerbernays, would say, I think we're going to have to get a sample of that toilet. And the students would just, I can't believe we're going to make this, so they're going to have to do it. And so it's back and forth, and nothing was ever anticipated when I was doing computation for that modeling. Long story short, we figured out the toilet connection had 190 micrograms per cubic meter. The first floor, once we closed that off and sealed it off, it went back to below 1. So this is the first peer-reviewed publication showing that this is where it's coming through with sewer connection. This really blew things up. I'm going to tell you that we had a hard time publishing it. As soon as we published it, I was invited to a closed-door meeting with DRB. DRB said, look, we've been investing in another research project. We've already put like $8 million into it. Then we have this same comment fill our floor space. But no one published it. And I was like, oh, well, that may be why I have such a hard time publishing it. So this now changed federal policy. It's now written into federal policy that this is a major pathway to consider protrusion. And what I want to say is why it's so important is that they had already spent like $100,000 mitigating this health, but they had not mitigated the exposure. And no one had ever documented that that was an important pathway. And I was ready to run away too. I was like, my model isn't validated. So thank goodness for multidisciplinary science, where the public health scientist actually wasn't thinking about the same transport side. I was like, wow, and we just held each other together through the whole process. So how was it getting in? Just so you know, I've lived in old houses. I've helped my husband change the wax seal. I actually have a very weak stomach, so I would be like, ah. But this is what a wax seal looks like. And it's really important. Like now my students and everyone, we care more about plumbing than we ever knew we would ever care about. And they are the ones that like pull these up. So all we had to do was replace that wax seal. We did it. It went back. It completely fixed the problem. So these are like, I call it DIY things that we don't do in our house, but it has a significant impact on our health. We published a paper that literally had plumbing in it. Never did I think I would be publishing things on plumbing. This was not where I thought my life would go. I often make a joke that my career took a dive in the toilet and I still survived. So people always say to us, you know, well, traps would keep that out. Traps work. And I say, yeah, when traps are working correctly, the heat gases out. But this is that wax seal. That is the only thing keeping sewer gas out. This connects directly to your sewer main. Without that wax seal, this trap here isn't doing anything. That's true even in this building, by the way. So these traps are very important, but only when they're working correctly. As I mentioned, so we published that in 2013. Federal policy was updated in 2015. That's pretty like, if you think of bench to bedside, this is like toilet to policy, very, very fast. And we continue to have that very quick impact. So we then did a study in Lexington where we developed a way to sample sewers. And our SOP for sampling sewers, we use neodymium magnets, and where do we do it? That ended up in Wisconsin's policy document, and they're driving sewer guidance right now, where while federal guidance is slower in kind of developing standard operating procedures. So right now we are really able to just provide scientific guidance for people who want to improve science. And it's really been impactful. The issue here is that who's responsible, right? So it's already tricky enough at Superfund sites, but we know that they're regulated. The issue and why it was such a can of worms is that it's typically it's a publicly owned treatment work, right? Or is it the homeowner? Because like I said, the toilet is something my husband and I changed together at that wax seal. Is it our responsibility? Was it the hazardous waste whoever caused the pollution? Or is it the sewer company for allowing sewer vapors to travel in? This is where it gets very messy because it starts to be like, it's their fault, it's my fault, it's your fault. And that's already an issue for Superfund, right? It ends up in legal battles. And so what we have really found in my group is I do a lot of stakeholder engagement and just trying to find how do we move through that chaos. I wanted to show this because there's someone I work with at Purdue. He looked at pure-in-place piping, which is a huge issue for aging infrastructure and repairing sewers. The way that sewer vapors during pure-in-place piping get into indoor air, and this is a significant health risk, is exactly the same as the traps. So we interact a lot. He called me one Friday night and said, hey, Kelly, can you run out of this public library? I said, where is it? I said, no, I'm in Lexington, you're talking about a public library in Louisville. But I quickly texted Lauren Heatherly, and she said, I know that public library. And then she got in touch with Luz, which you all may know, and they immediately helped this library. So they were actually getting vapors from the sewer moving into the children's space in the public library. People had gone to the hospital. So through the very pathways I'm talking about, this was from April 5th. And this is Andy Welton here from Purdue. He came down and did some testing and wrote up a whole site visit. And this is Lauren. I think this is Lauren right here with him. Yep. So this is just a really good story of how just a quick network, no funding, but a quick network of scientists who care about sewer vents and indoor air and understand how it comes together, pulled together and respond to the community. And EHS wrote up this really nice article about it in October, and I'll just read this. Although no grant mechanism connected us, our collaborative spirit, scientific expertise, and ability to interweave information to make sense of uncertainty motivated us to step forward when the community asked for help. And it says, we kept our focus fixed on the community's needs, and that makes a big difference in the way research can benefit society. I think that's true of all four of us. We responded, and to be honest, we would continue responding to communities, but they have really stopped asking for help. We have, but we're available as they need it. So these are issues that, affect Louisville. They are issues that are here to stay. No shortage of issues like this. So now I want to take you over to a huge site in California where we have been involved for a very long time. And then post-pandemic into very recently, we were able to make some positive impacts there. So I mentioned this kind of aging infrastructure issue, and that is one way that these, one of the pathways in which vapors are getting into sewers. So this, it's very typical that your sewers are broken, if you're not aware. In clay tile pipes, the joints are offset. The ground does not settle evenly, they're going to be offset. It's very common that you will have some corrosion, and then it's very common that we see infiltration occurring. We do a lot of sewer videos, municipalities have sewer videos. You can see groundwater infiltrate. So if that groundwater is contaminated, you're going to see, that's how vapors are going to get in there. Throughout the country, there is 1.3 million miles of sewers underground. And some of those sewers even intersect the groundwater table. So it is just a perfect conduit for the way that vapors can get into indoor air. This is a schematic that just shows that this is a sewer main. Imagine that you have a spill from an industrial site. Those spills can definitely intersect a sewer main. If there's any kind of breach in a sewer main, again, it would be unlikely there isn't a breach in a sewer main. The vapors or the liquids can come into there and then it flows down, and it's very easy to enter into a building. Every building has a lateral, and the only thing that separates that lateral from the indoor space are those traps that I've showed you. So if the traps are operating fine, great. If they're not, then you're going to have vapors get into them. In Mountain View, California, I started working there in 2015. We did some significant kind of wrap-up work in 2025. We'll still work out there. Sadly, the regional project manager, Alana Lee, unexpectedly and very tragically passed away in December 2025. That's why I put that. I continue to engage with that for office, but we'll see what happens going forward. She was phenomenal. She was the National Vapor Intrusion Lead for EPA, and she managed a number of sites out in Region 9. Really just a phenomenal woman. So she was a project manager for this site. As you can see, it extends quite a far. This was called the MEW area. And then it actually was part of a federal Superfund area, which included Moffett Field, NASA Research Park, and went all the way up. This area that's shown here is a trifluoroethylene plume. So it's long, it's been there a very long time, and it intersects a number of sewer lines. It had already been well known to have a vapor intrusion issue. So when she called me in 2015, vapor intrusion had already been well known, well established. In fact, this is like why Alana was named as the vapor intrusion lead was that NASA Ames folks helped kind of put vapor intrusion a lot on the map, I think nationally, because there was a joke that if rocket scientists can't understand vapor intrusion, how can we expect the rest of the country? And they were so upset about all the vapor intrusion in their community. So in 2015, she called me, she said, Kelly, we're not just having vapor intrusion, we're having sewer gas vapor intrusion. Can you come out and help? I said, well, I don't know what you need help with. And she said, we don't even know how to inspect it. So can you come out? So I took a bunch of my students, this is Alana here, and I had known this is a person who was the CEO of this company, Entanglement. It turned out he had an SBIR grant from NSF and CIEHS. This was his lead analytical chemist, and they were just developing a sensor. He was out there, of course, he was out there in the Bay Area, and I said, hey, Tony, can you come out? And he said, I'll do free sensing for you if you could do a real-time sensor, because he really wanted to work on a regulated site. And so we teamed up, we went out there, and then these are, I brought 3 of my students. So we did around the clock, 24-hour sensing. We were in the sewers, and I should tell you, Louisville headquarters is on the street. So all night long, the vans, it's like RVs, because people park away, would be flying by us. So this is us. We collected and monitored through manholes all night long. My students had little headlamps on. This is Tony and his sensor. At that time, it was like version 2, so it was actually in a transit van, but it still looked like it was wrapped in aluminum foil. And then these are my students. We collected, all different kinds of samples. This is a map. So this was the area that was known to have vapor intrusion. This is what we considered to be an expanded area because of sewer lines, where it was going to have vapor intrusion due to vapors moving through the sewer line. This is a large area. All of these yellow spots are spots where historically you can see through sewer videos that waste had been actually disposed of down the sewers, and so it had collected there, and then also through cracks had caused contamination in the surrounding soil. So these sewers, they're old, 60, probably installed in the 40s. So then in the 50s and 60s, during industrial operations, waste was just dumped down the sewer, and it just leaked into the surrounding areas. So we did a lot of characterization, and then we did modeling work of the sewers. We did a lot of sampling. The types of samples we collected were TO15, if you're familiar with those. We looked at all the sewer videos. We also sampled raw sewage water. And we started developing these ways to sample sewers without opening the manholes. We would put down passive samplers. One of my grad students developed the first way, and then we further refined it in Lexington. And now our approach is what is pretty much used nationally. So you don't have to pop open your sewer. You can keep the manhole shut. And it just hangs in there. You can leave it for up to a week. Again, the traps were the main thing that we said you have to look at the sewer mains, because if you have the sewer mains, like the house, that is very paradigm shifting for definitely industry folks and for consultants, because they kept saying, well, if I don't see it in the indoor air, then I'm not going to worry about it. The issue is that, well, what if it's, someone just dumped water down the trap, but a month from now they don't have it? You might still have the potential for the issue. And so that was our premise. We got pushback on that. So then we started doing controlled experiments in our lab, where we would build little pipe prototypes with joints that followed international plumbing code and US plumbing code. And we said, okay, what if you install 100% through the plumbing code? The plumbing code is actually to limit liquid leaks, not vapor leaks. It turns out that we were able to identify which fittings typically leak, even when they're installed through the code. And what we learned was that there's some that leak more, and that's also empirical what we see from regulators. And I'll say the one that is typically most problematic, I have this in my own home, is that the floor plug. The threaded floor plug is typically like a 3-inch you have in your laundry room or your basement. No one ever painted the walkway, and even if you do, we did it with a torque gauge, and you see that they're always leaking vapor. And so this was really helpful. people are like, oh, this is a problem. Just like me, I was a doubter until I saw the data. So with all of this then, I got another call back. And Alana called me, this was right around, I'm gonna say she called me here in July. And she said, Kelly, we published probably 3 or 4 papers on this work, and she said, hey, Mountain View, I've got another problem. The whole city wanted to approve these developments. And if you don't know, Mountain View, California is one of the most expensive areas in the country. They all approved to build new developments, townhomes, 26 at each parcel. They have 7 of them going up. But they're moving forward, and now they've had them sold out, but the city said, oh, we won't give you a certificate of occupancy until EPA goes in and says that they're safe and clear. She said, never in my career, I want to send out a certificate. She said, what should I do? And so she thought, I'm going to tell the developer that we're going to go in and sample. So she goes in and samples. What do you think happened? Oh, she has VOCs in the door. Then the developer says, oh, it's because I forgot to put water in all the traps. Well, she's a regulator and she already has hit. She says, well, we must have it in the sewer main. How do I know what we're going to know? It creates this whole thing. So they have to mitigate. But the developer doesn't want to pay. And now she has all the Superfund RPs. If you know anything about Superfund, they are lawyered up. They do not want to take on liability of it. Developer says, I already have these things sold, and I've got 7 booked away. They're selling for $2 million a piece, and each footprint, each development has 26 of them. So $52 million, and I've got 7 of them all the way up the way. So she's like, what am I going to do? And there, EPA doesn't need another person hating them. So we developed this sampling protocol. I said, okay. And then again, I do stakeholder engagement. So we got a lot of people on the phone. We got the people that the responsible parties were willing to work with. They came up with a scenario that was going to cost $500,000 for each development. The developer was like, I'm not going to do that. That's too much money for me. So we analyzed all of the data, and I just said, not just I, my group and with EPA, we said, what about this? We put in this siphon idea. The siphon I'm going to just get through this. So the siphon we evaluated all these different things that are in talking or possible mitigation scenarios. And the siphon was a gas trap. And then we went through, is it robust? How feasible is it? Is there an ease of operation? And what's the overall cost? So we just kind of qualitatively reviewed all of these. It turned out EPA said, here's the options. It wasn't a thorough cost analysis. It was just very much like, this is going to be ridiculous. This is not. Went to the developer and said, what do you think about these? Gas traps are going to cost between 5 and 10 grand. He said, I'll put them in. He moved forward, put them in. EPA did pre and post sampling. The health risk was gone. They continue to do monitoring as they would anywhere. The city took on long-term O&M, done. And the city, which they wanted to go on with the development, moved forward with over $250 million. And so it was done before the agreement closed out. This would typically have been kept up in legal battles forever. The RPs were not going to pay. They had already sold the units. So this is why Alana moved, and this is why Alana and I worked together so well. So we published this paper on just a decision-making tool. We didn't make decisions for anyone. We just said, these are some options. These are what the stakeholders have said. The developer, who actually had no liability, but I'll pay if they wanted to make it. 10 grand out of $52 million for a thing, the developer was very motivated to make it happen. The other thing I just wanted to say here is I had mentioned that early on we went in with that sensor company and had a van that said originally was kind of wrapped in foil. Really nice and exciting. This is actually the instrument now. So we were now one of the first beta users. Once it fits in the back of a truck, we've actually used this with Wayne State now. It fits in the back of an SUV. They now have sold many of them. So the idea, they are very good at moving forward. It's not just me, but we partnered with them and we continue to partner with them, and it's now moved forward. So just continuing long-term connections with people that actually know how to partner and move things forward, I'm going to say for the greater good. This is now used at many hazardous waste sites. It's not a perfect tool, it's one tool in the toolbox. And they have moved it forward. It's a company now that's been in business They're doing good work. And they say that one of the really good things for them was that they got to use that on a regulated site. That was really important buy-in from other people to know that they had used it in our regulated site, and we were the ones that got them there. So this is just to say, like, it was over $200 million in real estate development, advanced public health, and it was a feasible solution. So I'm really big on, I personally care a lot about the environment. I would pay a lot for a safe environment. Sadly enough, the reality is that some of the stakeholders I work with do not want to pay a lot. And if I don't accept that reality, I don't get to move forward very much. So that's what we work on a lot, is developing cost feasible solutions to protect the things that I value. And that's what my research has always worked on. These are the students I work on. And again, I had mentioned before that we really care about where our students end up. We want them to find their own path. So these are the students that I worked with. They are now in industry. They're now working for consulting companies. They're leading their own areas, and a lot of them work on vapor intrusion still. Evan works at the Army Corps working on PFAS. And so just a takeaway that I want to say is that what I love to do and what I do is we establish and reestablish mental models. I don't mind being wrong. I mind being wrong 100 times on the same problem. So like when I said, oh, I thought we had a computational fluid dynamics model when we went to Boston, and I thought we were right. And then we had to stand there and be like, oh, what do I have to refine? It's like we will establish and reestablish those mental models to define problems and develop solutions and really overcome some complex problems. And our overall goal is to just understand problems from multiple perspectives. And that's a really hard thing to do. It's hard to sometimes hear someone say, I care about the environment and public health. I care about plenty. I mean, it makes you angry. But then you got to say, okay, if you're the one that's actually going to pay, I'm going to try to find a solution that meets both of our needs. And to me, that's what drives me as a researcher. So thank you very much. And this is some of our Superfund research program people who mean a lot.
Any questions?
Going back to the source of the TCE, though, the one that had the plume from is obvious, but for general houses, where is the TCE fits into the system?
Yeah, well, we can start with that Boston site. So next to that site, it was a neighborhood, but it actually was an old, it was near railroad, and that had stored dry cleaning solvents. So it was just a small little storage thing. But in the 60s, that's where like the main dry cleaning solvents for the city had gone in and out of. So you wouldn't know it now, but when you went up to the site, there was no, that's why I say like it's kind of forgotten. No evidence now, but back in the day, and there was actually just a small little storage building, you would never know. But they would get drums. FERC within the time also had TCE. For spot cleaners, TCE was very important then. And so that's what that was from. And other sources like dry cleaning sites are very common for these. And dry cleaning sites, I like to say, are like as common as gas station. So dry cleaning sites, almost everyone around them is going to have a vapor intrusion issue. Also, gas station sites are common for vapor intrusion, but a lot of those aerobically degrade before the vapors will aerobically degrade before they get into the air. But there are many sources for vapor intrusion. It's some common ones and also industrial sites. But I like to mention dry cleaning sites because we just see those so often.
I was fascinated with the wax springs. So do you think that there's a lifespan on these things?
On wax rings?
Yeah.
I do think there is. Yeah, I mean, I'm not a plumber, but it's like, I actually, when I go to municipalities, I mean, I love to talk to them about these things. I haven't asked for a lifespan on them, but yes, I totally do. The other thing that I spend a lot of time talking when I go to municipalities are all these threaded couplings, like underneath your sink. I'm one of these people. So, you know, you undo it for some reason, right? Like you undo your sink. I'm gonna say I have my husband do it because I have a very weak stomach, but you have to get it clogged out. And I'm gonna say my husband never lines it up well and gets it as tight as possible. But what we've learned in our labs, like even if you did, it's still gonna leave some vapors, right? And so whether it's a lifespan or even just a reality, like they were never designed for vapors. So the takeaway is really that if you want to mitigate vapors, you need to do it outside the building, which is why we put that siphon there outside the building. It was just like, it was kind of like having a peat trap in the lateral, but then the city had to agree to clean it once a year. But yeah, I think they do, they get brittle. In fact, I had a link in there. It's like it was from Michigan Live. This guy was fascinating. He was kind of a Bill Nye science guy about plumbing. And he just gives all these things about plumbing they do not know about. So yeah, I mean, it's fascinating. You can go way into it.
Oh, okay. Thanks for an awesome talk. For the community that was next to that site you were first working in as an engineer, what sort of help did you see health outcomes?
So I like to say we're preventing risk. It would be, these are low risk. These are, you know, 10 to the -6. We're not going to see, especially in a community like that. What we do see are concentrations that are above the target. Okay? But we did not see like observable health risks. So when I'm saying risk, I'm actually saying above the target. Right? Yeah. And what I'll also just say, like a big kind of catalyzing event was that they detected that school, I even kind of pointed to there was a school. That actually wasn't a big protrusion, but that really did motivate. So it was a mobilizing event because that was a LEED certified school and the community had really wanted that school. Then, as part of the protrusion investigation, they did not expect to see anything in that school because it was far enough from that rail line. And they also didn't expect to see TCE per se because it was mostly a PCE issue. But what happened was, and I always say this, when you go in and sample in your area, you will find something. We are not very good about our indoor air. They got TCE. The community was very upset. But one thing, it was a LEED certified building. And so their mental model was, this must be vapor intrusion. Also, someone lying to us, right? It felt like betrayal. I can understand that, right? I can understand it. And so then that just became such a thing of like, we need to understand, the state, we need to understand what's going on. I said, I would really well understand it so well until I didn't understand it, right? But that was it, so.